6a. Sketch. One axis labeled V and the other labeled I, either way round and gradual curve from origin curving such that Vi increases. Explanation. As current temperature increases so resistance increases. So more voltage required for same increase in current. Or if V on y-axis, gradient must increase. Or if V on x-axis, gradient must decrease. 6 by 9.0 volts, 12.03.0. 6 BII, 2.1a, I equals VR or I equals VR or 9, 0 quarters point 2. 6 B0a, 6 BIV ammeter reading 2.1a. 6 BV19W. P equals V or P equals V or 9 2.1. 9 Fig. 9.1 shows current potential difference page D, graphs for a resistor and for a thermistor. A. Calculate the resistance of the thermistor when the P, D, across it is 7.0 V. I equals VR in any form or R equals VI or 7, 0 quarters point 6. 1.5 ohms. B. In table 9.1, tick the boxes that indicate the effect on the resistances of the resistor and of the thermistor when the P, D, across them is increased from 0 to 7.0 V. Resistor. Resistance is constant. Thermistor. Resistance decreases. C. The thermistor and the resistor are connected in parallel to a 7.0 volts supply. Calculate. I. The current from the supply. 4.6 plus 4.6. 9.2a. Or, combined resistance equals 1, 522 over 1.52 plus 1.52 equals 0.76 ohms. I equals 7. 0 over 0.76 equals 9.2a. E. The energy transferred from the supply in 5.0 minutes. E equals IVT or in words are 9.2 times 7 times 5 times 60. 19,000 J. 10.8 The electrical energy produced by a power station is transmitted over long distances at a very high voltage. Explain why a very high voltage is used. If voltage is very high, current is very low, not if resistance is low. If current is low, thermal energy generated power loss is low. If current is low, thinner, lighter, cheaper transmission cables with less resistance, cheaper pylons can be used cheaper. B. Fig. 10.1 represents a transformer. I. The primary coil P has 4,000 turns and an input of 120 V. The secondary coil S has an output of 9.0 V. Calculate the number of turns in the secondary coil. Vp, Vs equals Norper, Ns in any form or Ns equals Norper Vs, Vp or 4,000 times 9 120ths. Ns equals 300. E. State a suitable material for the core of the transformer. Iron or soft iron. 8 Fig. 8.1 shows a circuit. The lamp has a resistance of 3.0 ohms. Line XY represents a uniform resistance wire of resistance 6.0 ohms. A. Calculate the reading on the ammeter. Rs equals R1 plus R2 plus R3 in any form or Rs equals R1 plus R2 plus R3 or Rs equals 3 plus 2 plus 6 ohms or Rs equals 11 ohms. And V equals IR in any form or I equals VR or I equals 12/11ths A. I equals 1.1a. B. Fig. 8.2 shows the circuit with a different connection to the resistance wire and an added resistor. The length XY of the whole resistance wire is 2.0 meters. The contact is made at Q where the distance XQ is 0.60 meters. Calculate the resistance of the circuit. Uses resistance of wire proportional to length or resistance XQ equals 6 ohms 0, 6 halves 0.0 ohms or 1.8 ohms. 1 Rp equals 1 R1 plus 1 R2 or Rp equals R1 R2 R1 plus R2. 1 Rp equals 1 over 1.5 plus 1 6 times 0, 6 halves. Or Rp equals 1.5 times 6 times 0.62 over 1.5 plus 6 times 0, 6 halves. Or Rp equals 1.5 times 1.8, 1.5 plus 1.8 equals 0.82 ohms. R equals 3 plus 2 plus 0.82 equals 5.8 ohms. 9.8 State the name of the logic gate with the symbol shown in Fig. 9.1. NAND. B. State the name of the logic gate with the truth table shown in Table 9.1. NOT. C. Fig. 9.2 shows a digital circuit. Complete the truth table in Table 9.2 for this circuit for all possible combinations of input. AB first row 11 and fourth row 00. AB second and third row 01 and 10 in any order. E first two rows 01. E last two rows 11. 10. 8 Fig. 10.1 is a simplified top view of a flat coil. There is an alternating current A, C, in the coil. Describe the magnetic effect of this alternating current. Magnetic field produced. Magnetic field, magnetic flux, magnetic effect, magnetism. It alternates, changes direction, reverses. B. Fig. 10.2 shows a pan placed above the coil. The base of the pan is made of steel. E. M. F. P. D. Voltage. C. The pan contains water. State and explain the effect of the quantity induced in part B on the temperature of the water in the pan. Temperature increased. Current in base of pan. Thermal energy produced in base of pan. 7 Fig. 7.1 shows a horizontal conducting wire XY between two opposite magnetic poles. Wire XY forms a circuit with an ammeter. A. Explain why the reading on the ammeter is 0 when the wire XY is not moving. No cutting of magnetic flux, magnetic field. B. The wire XY is moved and there is a deflection on the ammeter that indicates there is a current in the wire from X to Y. On table 7.1, tick one box to indicate the direction of the movement of the wire XY and explain your answer. To the top of the page, RH box. Current, motion and magnetic field. Mutually at right angles. Magnetic field from left to right. C. State what is observed on the ammeter when the wire XY is moved. I. In the opposite direction to part B, opposite current direction, opposite deflection on ammeter. E. In the same direction as part B, but at a greater speed, greater current deflection. 8. Define electromotive force E, M, F. Energy supplied by a source in driving charge around a complete circuit, energy needed to drive unit charge 1 coulomb. Round circuit. B. Fig. 8.1 shows a source E of E, M, F. 60 V in a circuit. The heater H has a resistance of 22.5 ohms and the potential difference, page D, across it is 45 V. Calculate I. The power of the heater. P equals 90 W. P equals VI in any form. V R or I equals 2. E. The P, D, across resistor X. P, D, equals 15 V. P, D, equals 60 to 45. E. The current in the 10 ohms resistor. I equals 15 tenths equals 1.5 A. I equals V R or V equals IR in any form. 9. Write down the truth table for an OR gate. IPIPOP 00 01 10 11 IPIPOP 000 011 101 111 B. Draw the symbol for a NOR gate. 2 inputs to curved face, sharp end with small circle and 1 output. C. Fig. 9.1 shows a digital circuit designed to produce the values shown in table 9.1 for the output S from the 2 inputs P and Q. Table 9.1 is the truth table for the circuit shown in Fig. 9.1. Complete the column for point R in table 9.1. 1, 0, 1, 0. E. State which type of gate is used for gate X. Explain your answer. And input 1 and 1 gives output 1. Any 0 input gives 0 output. 6 Fig. 6.1 shows 2 bars magnets. A. On Fig. 6.1, sketch the pattern and the direction of the magnetic field lines between the bar magnets. Minimum of 1 arrow on a field line pointing N, right pointing arrow S and not contradicted. Central line perpendicular to poles of magnets and at least 2 other correct field lines. B. Fig. 6.2 shows the same bar magnets with a coil of wire between them. I. Name the parts labeled A in Fig. 6.2 are slip rings. E. The coil of wire is rotated in the direction shown in Fig. 6.2. On Fig. 6.2, draw an arrow to show the direction of the current in the coil. Explain your answer. Minimum of 1 arrow, pointing clockwise, on the wire, not contradicted. Field direction, motion of wire and induced current are mutually perpendicular. E. Explain how rotating the coil in Fig. 6.2 continuously causes the galvanometer needle to show an alternating current. As coil rotates, it cuts magnetic field between the magnets. This induces an E, M, F, voltage P, D, in the coil. This produces a current in the coil transferred to the galvanometer via the slip rings and carbon brushes. Direction of current flow changes with each 180-degree rotation of coil. 7 Fig. 7.1 shows a circuit including a 12 volts battery and 2 identical lamps. 8. The 12 volts battery consists of cells connected in series. Each cell in the battery has an electromotive force E, M, F, of 1.5 V. Determine how many cells are in the battery. 8 cells. BI, when the switch is closed, the ammeter reading is 2.4 A. Calculate the total resistance of the circuit. 12 halves 0.4 equals 5.0 ohms. R equals VI in any form. Each lamp has a resistance of 3.0 ohms. Calculate the resistance of Q. Resistance of Q equals 5 to 1.5 equals 3.5 ohms. 1 R equals 1 R1 plus 1 R2 or R equals R1 R2 R1 plus R2. CI, on Fig. 7.1, draw the symbol for a voltmeter that measures the potential difference page D, across the two lamps. Correct voltmeter symbol connected correctly across both lamps. Calculate the power supplied to one lamp. 4.3 W. P equals IV in any form or 1.2 times 3.6. 3.6 V or 1.2 A. 8A radio is connected to the mains supply using a step-down transformer. 8. Draw a labeled diagram of the structure of a basic step-down transformer. Labeled diagram showing labeled iron core, 2 coils, labeled primary and secondary, a round core and connected to separate circuits. Fewer turns on labeled secondary coil. B. Explain the operation of a basic transformer. Primary voltage causes an alternating current in primary coil. Produces a changing magnetic field. Changing field induces PDE, M, F, in secondary coil. C. The voltage of the mains supply is 230 V. The output voltage of the transformer is 6.0 V. Calculate the value of the turns ratio. Give your answer to two significant figures. 0.026 Ns per Nepper equals versus Vp in any form. 9 Fig. 9.1 shows a digital circuit. AI, explain what is meant by digital. A signal that has one of two possible states. Table 9.1 is a truth table for the digital circuit shown in Fig. 9.1. Complete the columns C and D in Table 9.1. A, B, C, D. 0001. 0101. 1001. 1110. B. State the single logic gate that would produce the same output D from inputs A and B. NAND. 7. 8. Define potential difference page D. Work done in passing charge through across a component. Work done per unit charge. B. I. State the equation which defines electromotive force E, M, F. E. Definition of EMF, E equals WQ. The E, M, F, of a battery is 9.0 V. The battery is in a circuit. Calculate the work done by the battery when it moves a charge of 30 C around a complete circuit. 270 J. W equals EQ or 9.030. C. A circuit consists of AD, C, power supply, a lamp and a thermistor. I. Draw a circuit diagram of these components connected in series. Correct symbols for D, C, power supply, a lamp and a thermistor. 3 components in a complete series circuit. E. Explain what happens in the circuit you have drawn in CI when the temperature of the thermistor is increased. Resistance of thermistor decreases when temperature increases. Resistance of circuit decreases or greater current in lamp so brightness of lamp increases or greater page D, across lamp so brightness of lamp increases. 8 Fig. 8.1 shows a horizontal, flat coil in a magnetic field. The coil is connected to a cell. The coil rotates. 8. Determine the direction of movement of the side AB relative to the plane of the coil. Downwards, into the page, anti-clockwise. B. Explain how you determined the direction in A. Current, magnetic field, motion at right angles to each other. Magnetic field from left to right, N to S, and current is from A to B, positive to negative. C. State and explain what happens to the coil as it reaches the vertical position. At vertical the coil stops or at vertical the coil overshoots and comes back or the coil vibrates about the vertical. Any one from. As the coil approaches vertical the turning effect decreases. At vertical the turning effect is 0. Past vertical the turning effect reverses, changes direction. D. To operate as a motor, a split ring commutator and brushes are added to the parts shown in Fig. 8.1. Explain the effects of the split ring commutator and the brushes on the action of the motor. Reverses the current. Any two from brushes ensure current is maintained. Coil rotates continuously, continues to move in the same direction. Allows current to change direction without wires getting tangled. Reverses the current every half turn, 180 degrees, or reverses the current when the coil is vertical, at right angles to the magnetic field. 0625_S19_Ms_41.pdf. 7 Fig. 7.1 shows a circuit diagram that includes component X. 8. State the name of component X. Thermistor circa A. O. B. The electromotive force E. M. F. of the battery is E. The switch is closed. The potential difference page D. across the 30 ohms resistor is V30. The P. D. across the 20 ohms resistor is V20. The P. D. across component X is Vx. State an equation that relates Vx to I, V30. Vx equals V30. E and V20. Vx equals EV20 in any form. C. The E. M. F. of the battery is 6.0 volts and the resistance of component X is 15 ohms. Calculate I. the total resistance of the circuit. 7C1. E. the ammeter reading. D. the temperature of component X increases. State and explain what happens to the ammeter reading. Resistance of X decreases. Ammeter reading, it increases and total resistance of circuit decreases, more voltage across 20 ohms resistor. 8A student turns the handle of an alternating current A, C, generator and the coil rotates. Fig. 8.1 represents the structure of the A, C, generator. 8. There is an alternating voltage output between the two terminals. I. Explain why rotating the coil produces an output voltage. Magnetic field mentioned. Coil wire cuts magnetic field or changing magnetic field through coil. E. M. F. Voltage induced or produced by electromagnetic induction. E. State the position of the rotating coil when the alternating output voltage is at a maximum value and explain why the maximum output occurs at this position. Plane of coil horizontal or in position shown in diagram. Coil cutting magnetic field the fastest. B. A lamp and an open switch are connected in series to the output terminals of the A, C generator. The switch is closed and the lamp lights up. The student has to apply a greater force on the handle. Explain why a greater force is needed to keep the lamp lit. Current in coil or energy supplied to lost from lamp. Current in magnetic field experiences a force. Student must do more work, supply more energy needed. Opposes the change causing it greater force to do more work. 0625_S19_Ms_42.pdf. 8A. A conducting sphere is mounted on an insulating stand. Explain how you would use a positively charged rod of insulating material to charge the sphere by induction. Bring charged rod close to sphere touching sphere. Earth sphere are equivalent. Remove earth connection and keep rod close to sphere until earth removed. B. Fig. 8.1 shows an electronic component. Light emitting diode or LED. C. In the space below, write down the truth table for a NAND gate. Correct labeling of IP and OP, all IP numbers correct in any order. All 4 rows of numbers correct, in any order. D. Fig. 8.2 shows the connections to 2 logic gates. Table 8.1 shows part of the truth table for the arrangement of logic